Dimensions and dimensional analysis. Dimensions. The dimensions of a physical quantity are the powers to which the fundamental quantities are to be raised to represent that physical quantity. For example, force equals to mass into acceleration equals to mass into length into 1 by time square. So, dimensional formula of force equals to under big bracket mlt minus 2 or m1 l1 t minus 2. The dimension of mass in force is 1 and the dimension of length in force is 1 and dimension of time in time in force is minus 2. Dimensional formula, the expression which show that which of the fundamental quantities and with what powers enters into the derived unit of physical quantity is known as the dimensional formula of that physical quantity. For example, a dimensional formula of A equals to m0l2t0. Dimensional formula. Dimensional equation, the equation obtained by equating the symbol of a physical quantity with its dimensional formula is called dimensional equation. For example, F equals to mlt minus 2. This is the dimensional formula. Now, dimensional formula for fundamental quantities. Quantity length L, mass m, time t, electric current A, temperature K, luminous intensity CD, amount of substance mole. Dimensional formula of some derived quantity. Physical quantity force, mass into acceleration unit Newton. Dimensional formula mlt minus 2, work force into displacement unit joule. Dimensional formula m into L to the power 2 into T to the power minus 2. Gravitational constant 4 into distance square by mass square. Unit Newton meter square by kilogram square. Dimensional formula m minus 1 L3 L to the power 3 into T to the power minus 2. Stress force by area Newton per meter square unit. And dimensional formula m into L to the power minus 1 T to the power minus 2. Note: dimensionless physical quantity, plane angle, solid angle, a specific gravity, a strain, refractive index. These are the dimensionless physical quantity. Now, second, quantities having same dimensions. Ma, momentum and impulse have same dimension. Work, energy and torque have same dimension. Pressure, stress and modulus of elasticity have same dimension. C into R, L by R and root LC have same dimension of time. Different types of variables and constants. 1. Dimensional variables. The physical quantities which possess dimensions and have variables values are called dimensional variables. For example, area, volume, velocity, force, etc. Now, dimensionless variables. The physical quantity which have no dimensions but have variable values are called dimensionless variables, like angle, a specific gravity, a strain, sin theta, cos theta, etc. Third, dimensional constant. The physical quantities which possess dimension and have constant values are called dimensional constant, like Planck's constant, gravitational constant, a speed of light in vacuum, etc. are dimensional constant. Fourth, dimensionless constant. The quantities which do not have dimensions but have constant values are called dimensionless constant. For example, pi, e, pure numbers like 1, 2, 3, etc. Principle of homogeneity of dimensions. According to this principle, the dimension of all the terms occurring on both sides of the equation must be same. For example, let us have a physical relation in terms of fundamental quantity m to the power a into L to the power b into t to the power c equals to m to the power x L to the power y t to the power z. Then according to the principle of homogeneity, a equals to x, b equals to y, and c equals to z. Example: the speed of light c, gravitational constant in g, and Planck's constant h are taken as the fundamental unit in a system. Find the dimension of length and time in this new system of unit. We have E equals to h nu. We have E equals to h nu. This implies h equals to E by nu. Now, dimension of E is m into L to the power 2 into t to the power minus 2 by 1 by t equals to m L to t minus 1. Similarly, we have f equals to gmm by r square, or g equals to fr square by m square, using dimensional formula mlt minus 2 into L by m2. So m to the power minus 1 L to the power 3 into t to the power minus 2. Solution. Hence dimension of C, L t to the power minus 1, equation 1. Dimension of G, m minus 1 L to the power 3 t to the power minus 2, equation 2. And H, dimension of H, m into L to the power 2 t to the power minus 1, equation 3. From equation 1 we can write CQ equals to L to the power 3 t to the power minus 3, and from 2 and 3 we have G into H equals to L to the power 5 t to the power minus 3. Hence G into H by CQ equals to L to the power 5 t to the power minus 3 L to the power 3 into t to the power minus 3 equals to L square. Hence L equals to G to the power 1 by 2, H to the power 1 by 2, and C to the power minus 3 by 2. Again, t equals to length by speed. So G to the power 1 by 2, H to the power 1 by 2, C to the power minus 3 by 2 by C equals to G to the power 1 by 2, H to the power 1 by 2, C to the power minus 5 by 2. Answer. Now, use of dimensions, conversion of unit of one system to another. It is based on the fact that product of numerical value contained in and unit of physical quantity remains constant, that is, larger unit has a smaller magnitude, or n into u equals to constant. If a physical quantity has dimensional formula m to the power a, L to the power b, t to the power c, and units of that quantity in two systems are m1 to the power a, L1 to the power b, t1 to the power c, and m2 to the power a, L to the power b, and t to the power c, then n1 u1 equals to n2 u2. Hence n2 equals to n1 into m1 by m2 to the power a, L1 by L2 to the power b, t1 by t to the power c, where n1 and n2 are numerical values in first and second system of unit. For example, the density of a material in CGS system is 8 gram per cm3. In a system if unit in which unit of length is 5 cm and unit of mass is 20 gram, what is the density of material? We know that density of the dimension of density are m L to the power minus 3. So n1 u1 equals to n2 u2, where n1 u1 is first system and n2 u2 represents second system. Hence n2 equals to n1 by n1 into u1 by u2, n1 into m1 by m2 into L1 by L2 to the power minus 3. Now n1 into m1 by m2, L2 by L1 to the power 3. Now put both value. We have n1 value given 8 and m1 equals to 1 gram, m2 equals to 20 gram, L2 equal to 5 cm and L1 equal to 1 cm. Solving we get 50. That is density of material in new system is 50 unit. The value of gravitational constant is G equal to 6.67 into 10 to the power minus 11 Newton meter square per kg square. In SI unit, convert it into CGS system of unit. The dimensional formula of G is dimensional G equals to m to the power minus 1 L to the power 3 T to the power minus 2. Now we have formula N2 equals to N1 m1 by m2 to the power minus 1 L1 by L2 to the power 3 and T1 by 2 to the power minus 2, or this N2 equals to N1 into m2 by m1 L1 by L2 to the power 3 and T2 by T1 to the power 2. Now 6.67 into 10 to the power minus 11, 1 gram by 1 kg, 1 meter by 1 cm, 1 second by 1 second, or 6.67 into 10 to the power, and solving we get finally 6.67 into 10 to the power minus 8. Thus the value of G in CGS system of unit is 6.67 into 10 to the power minus 8 dynes centimeter square per gram square. To check the dimensional correctness of a given physical equation, every physical equation should be dimensionally balanced. This is called the principle of homogeneity. The dimensions of each term on both sides of an equation must be same. On this basis, we can judge whether a given equation is correct or not, but dimensionally correct equation may or may not be physically correct. Example, test the accuracy of the equation delta equals to m into g into L to the power 3 by 4b into d to the power q into y. Dimensionally, where g is the depression produced in middle of a bar of length L, breadth b and depth d, when it is loaded in the middle with mass m, y is the Young's modulus of the material of the bar. Here the dimension of left hand side of equation delta equals to L and RHS mg LQ by 4b dqy. Now mass dimensional formula of mass is mLt minus 2 into LQ by L into LQ ml minus 1t minus 2 equals to L, because dimension of LHS is equal to dimension of RHS. So the above equation is dimensionally correct. Find the dimension of A गुने B in the relation P equals to B minus x square by AT, where P is the power, x is the distance, T is the time. Dimension of B, that is dimension of x square, equals to L square. Dimension of x square by AT equals to dimension of P, and dimension of A equals to dimension of x square by pt equals to L square by ml 2t minus 3 into t m minus 1t minus 2. Hence dimension of A into B, L2 m minus 1t square m minus 1 L square t square. Check the dimensions whether the equation tan theta equals to rg by v square is correct, where r is radius of the path, g acceleration due to gravity, and v speed of the velocity, theta is the banking angle. The dimension of LHS M0 L0 T0 because tan theta is a constant without dimension, and the dimension of RHS Rg by V square LT minus 2 by L square T to the power minus 2 equals to M0 L0 T0 because RHS equals to LHS. Since both sides of equation have same dimension, therefore given equation is dimensionally correct. Note: the equation tan theta to Rg by V square is not physically correct. The correct equation is tan theta equals to V square by Rg. 2. The dimensionally correct equation need not to be physically correct. Question: show that the expression of time period t of a simple pendulum of length L is given by t equals to 2 pi by root Lg is dimensionally correct. Dimension of LHS equals to t. Dimension of RHS dimension 2 pi under root L by G or dimension under root L by LT minus 2, which comes out to be dimensional t. Hence dimension of LHS equals to RHS. The velocity v of a particle depends upon the time t. According to the equation, v equals to a plus bt plus c by d plus t. Write the dimension of a, b, c and t. From principle of homogeneity, dimension of a, dimension of v equals to dimension of a. So dimension of a is LT minus 1. Again, dimension of v equals to dimension of b into t. Hence dimension of b equals to dimension of v by t. Solving, we get dimension of b equals to LT minus 2. Similarly, dimension of t equals to dimension of t equals to t. Again, dimension of v equals to dimension of c by dimension of d plus t. So dimension of c equals to dimension of v guna dimension of d. Hence dimension of c equals to LT minus 1 into t equals to L. Answer. 3 में deriving the relation among physical quantities. By using the principle of homogeneity of dimensions, we can derive an expression of a physical quantity. If we know the various factors on which it depends, let physical quantity x depends on other quantities p, q and r, then we can write x equals to k into p to the power a, q to the power b, r to the power c. Where k is a dimension less constant whose value can be determined by experiment or otherwise, but not by dimension. By equating dimensions of both sides of equation, we can get required relation between the quantities. Solution. For example, given that the time period t of oscillation of a gas bubble from an explosion under water depends upon P, D and E, where P is the static velocity, the density of water, and E is the total energy of explosion. Find dimensionally a relation of T. We have T proportional to P to the power A, D to the power B, E to the power C. Suppose then T equals to K into P to the power A, D to the power B and E to the power C. So dimension of T equals to dimension of K into B, P to the power A, D to the power B, E to the power C. Here the K is a dimensionless constant, so we remove the K from the equation. Now Now M0L0T equals to dimensionally P to the power A, dimension D P to the power B, dimension E to the power C equals to ML minus 1 T minus 2 to the power A, ML minus 3 whole to the power B, ML2 T minus 2 whole to the power C. Now M to the power A plus B plus C into L to the power minus A minus 3B plus 2C T to the power minus 2A minus 2C. Now using the principle of homogeneity, equating the power of M, L and T both sides, we have A plus B plus C equals to 0, minus A minus 3B plus 2C equals to 0 and minus 2A minus 2C equals to 1. From 3 A plus C equals to 1 by 2, 4. Using this in 1, we get D equals to 1 by 2. Now from equation 1 multiplied by 3 plus 2 gives solving, and 4 multiplied by 2 minus 6 gives C equals to 1 by 3. Hence from 1 A equals to minus 1 by 2 minus 1 by 3 equals to minus 5 by 6. Hence required relation is T equals to K into P to the power A D to the power B E to the power C equals to K into P to the power minus 5 by 6 D to the power 1 by 2 E to the power 1 by 3, or T equals to K into D to the power 1 by 2 E to the power 1 by 3 by P to the power 5 by 6.